When we're simplifying radicals, it comes like what came first, the chicken or the egg? Is what came first? Did radicals come first or did fractional exponents come first? Don't know. But what the radicals do is they really follow the properties of exponents. Now, you're not going to think one iota about the whole thing of, well, gee, I'm using the properties of exponents. You're going to say, I'm using the properties of radicals. And the first property of radicals is going to be the product rule for radicals. That says if I have the nth root of A times the nth root of B, it's the same thing as I can bring it under a single radical. It's the nth root of A times B. So here it is. Here's how it coincides with the property of exponents. If I take it the nth root of AB, it's really taking the radicand, which is A times B to the 1 power, rewriting it as a fractional exponent. It's A times B to the 1 over n power. Property of exponents then would say, well, what you're going to do is the exponent on B is 1, the exponent on A is 1. You're going to multiply the exponents by 1 over n. What that gives you now is A to the 1 over n times B to the 1 over n. That's just using the property of exponents. That's similar to that second problem, or I guess it was the first problem that you worked on your review sheet. Now, what do I know that A to the 1 over n is? Well, it's just the nth root of A, and B to the 1 over n is just the nth root of B. So that says if I have two radicals that are being multiplied that are separate, their indices are the same, I can bring them under a single radical. If I have something which is under a single radical and they are multiplied, I can break them apart into the individual factors. So I can put it together and I can take it apart. And it's all because of the properties of exponents. And like I said, you're not going to think about any time you work with radicals, oh, I'm using the properties of exponents. No, you're going to use the properties of radicals. That's what you'll think anyway. If I look at the cube root of 5 times the cube root of 4, this is the same as the cube root of 5 times 4, which turns into the cube root of 20. Now, we're not simplifying radicals yet, so I don't look to see is there going to be something that I can do with this. That's not what the issue is with this. If I have two things that are multiplied together, that says, and they're both with an index of 4, there's the multiplication. I can bring it under a single radical, and they're multiplied. So that now I perform the multiplication. This is 18x cubed. Here's a blob, which is an x minus 5 to the 1. There is an x minus 5 to the 4. Set of parentheses. I don't care what's in the parentheses. Don't care. I just care that the same. Under a radical with the same index, this becomes the 6th root of, this would be x minus 5 to the 1 times x minus 5 to the 4. And if the bases are the same, what do we do with the exponents? Add them, right? A to the m times a to the n is a to the m plus n. So this would be that set of parentheses, really don't care what's in it, to the 5th power. Now I can write down x minus 5.